Welcome back. You ask how to solve this one. Which segment is the geometric mean of AC and CD? And then we're going to find the length of segment BD, AD, and AB. Let's review quickly. We have a geometric mean theorem. Geometric mean theorem, we have two. One is altitude. Remember, we said we can write down them in words. We say altitude, altitude, stay at the mean place. Then we have segment 1 and segment 2 equals, because this is what happened. You have a right triangle and you have altitude. So this is a right angle. This is also right angle. Let me give some color. Right angle, right angle, right angle. Now, this altitude, I'm going to color it as blue. I'm going to name this triangle A, B, C. You see, altitude is BD. Therefore, your two segment is AD, CD. And I can fill in here. I'm going to say my two segments is AD and CD. My altitude is BD. So this is how you write a geometric mean proportional relationship for the altitude theorem. Let's look at another one. We have another one called the leg. So we have leg gonna stay at the mean place. And here we put hypotenuse. And here we put the segment that is adjacent to this leg. Okay? And then let's come back to look at it. Hypotenuse is AC. Therefore, I'm going to put down AC here. You have two sets of leg here. I'm going to pick one to help you review this. I'm going to pick leg BC. BC. And I'm going to go ahead and color the segment that is adjacent to this leg BC. All right? Now, we're going to replace it. We're talking about the leg BC. And then we're going to use the segment that is adjacent to this leg. We can also call it a projection. We say CD. That's it. That is what you learned from your previous lesson called geometric mean theorem. With this in mind, I think we can go ahead, solve the first part. What is the geometric mean of AC and CD? What is AC? Let's find AC. AC is right here. So AC is hypotenuse. So let's write down AC. What are you? I am hypotenuse. What is a CD? I'm going to choose a different color. Color CD. Oh, CD is right here. Let me get an even more obvious color right here. CD is right here. So we realize CD is a segment that is adjacent to which one? To BC. So BC is a leg. All right? Now we know we're going to use a leg theorem. So we're going to write down leg, and hypotenuse. Instead of writing the segment that is adjacent to this leg, I'm going to write down projection. Okay? All right. Let's fill it in. See if we get it correctly. Leg is BC. Hypotenuse is AC. And that projection is CD. And check. This BC stands at the mean place of mean. Therefore, the first part, we answer which segment? It's segment BC. If you write down segment CB, it is also correct. All right, let's continue to find the length of segment BD. BD, what are you? Then we come here, we take a look at this little triangle. And then we can, if you want, you can redraw it. This little triangle, okay? And this is B, this is D, and this is C. So BC is 10, and CD, DC is 6. Are you able to find BD? That's right. Did you think, or did you say, we're going to use Pythagorean theorem? So C squared is A squared plus B squared. What is missing? B squared is missing. So B squared is C squared minus A squared. We don't want B squared, we want B. So we put them under the radical. Now we start to plug in. And C squared, 10 squared, 100. A squared, 6 squared, that's 36. And 64 and the square root. So B is 8. B is BD, so BD is 8. Now you just solved what is BD. All right, let's continue to find what is AD. AD is here, AD. All right, so you already found BD. BD is altitude. Why don't we use altitude theorem, the one we just reviewed earlier? So altitude. We have a segment 1 and segment 2 equals. Now, altitude is BD. You just find out that is 8, so I'm going to go ahead and plug in 8. And this BD divided AC into 2 segments. One is CD, one is AD. I don't know. CD is 6. AD, I don't know. I'm going to put AD here, but we will find out very soon. Now you can use cross multiplication. So AD times 6 is 8 times 8, 64 divided by 6 each side, 64 divided by 6. It's not simplified enough, so we're going to divide by 2, and we have 32 over 3. Okay? All right, that's how we find the length of AD. All right, let's keep going. Our last task here is to find what is the segment length of AB. To find the length of AB, since we just found what is AD, this we know, what is AD, this we know, this we know, you definitely can use Pythagorean theorem to find the length of AB easily, because if you redraw it, the length of AB is actually B. And this is A, this is C. So you can use A squared, B squared, C squared. You can use that to find it easily. But since we just learned this geometric mean theorem, why don't we try it one more time? See if we can use geometric mean theorem to find the length of AD. Okay? All right. So to find the length of AB. All right. So I'm going to say AB. AB would be the leg. I'm going to use leg theorem. AB. That's the leg, which means here I need to put a hypotenuse. Here I need to put the projection, or if you like, you say the segment that is adjacent to this leg. All right, hypotenuse. Remember AD, we just found what is the length of AD. Okay, AD is 32 over 3. So we're going to write down here 32 over 3. So if I add 32 over 3 to 6, that gives me hypotenuse. So I'm going to write down 6 plus 32 over 3. It looks a little bit busy. It's okay. We're going to get everything done beautifully. All right. What is, so since I choose AB, I will need the leg that is adjacent, the segment that is adjacent to this leg, okay? So I'm going to use this to blue. And then I'm going to put, now, a beautiful relationship. We're going to find AB. You can clean up the top a little bit. So 32 over 3, that is 10 and 2/3. 10 and 2/3 plus 6, that is 16 and 2/3. Is it better for you? So please do not change into decimal. When you change into decimal, you'll lose value. If you don't keep it, something good gonna happen. We might be able to find a whole number. You never know. Okay? So next step, cross multiplication. I say AB times AB is AB squared. By the way, if you don't like to write down AB, you definitely can write down X. And then later you just say X is AB. Okay? I will do this for you. I don't know. So AB, you're called X. So X, X. Now, is it better for you? Yeah? Okay. X squared is, we're going to use 16 and 2 over 3rd times 32 over 3. All right, you don't want to have X squared because you want to have X. What is the length of AB? So what is the value of X? Therefore, you want to put these two guys under the square root. Okay? All right. Once again, friendly reminder, do not convert into decimal. And just do a multiplication of fraction. Okay? All right. Now, to save your time, I already did it before this. And I have under the square root. I'm going to put down here. Okay? Because I run out of space. I'm going to put down here. Under the square root, I have 1600 over 9. Remember what we said earlier? If you don't convert to decimal, sometimes you might have a whole number. That's what happened to us. All right, so get it out of the radical. And we have 40 over 3. Yes, there you are. We have AB. AB length is 40 over 3. That's it. Thank you for asking this question.